Good morning, students. Today we are going to discuss about the capacitors. In the previous class, we discussed about the definition of the capacitor, working of the capacitor, charging, discharging of the capacitor, and the classification of the capacitor, different types of classifications, and also lightly discussed about the specifications. Now we are going to discuss about the specifications and remaining topics in detail in this class. Specifications of capacitor. Different specifications of capacitors are capacitance, dielectric constant, dielectric strength, tolerance, voltage rating, dissipation factor, power factor, equivalent series resistance, leakage resistance, insulation resistance, temperature coefficient, voltage coefficient, and stability. These are the specifications of the capacitors. For choosing a proper capacitor, we need the proper specifications of the capacitor. If we know all the specifications of the capacitor, we can choose a right capacitor for our application. Now we are trying to discuss in detail about these specifications. The first specification is capacitance. So all these specifications are mentioned in data sheets of the component. So what is the capacitance of a capacitor? Capacitance is expressed in farads or in microfarads. The units of the capacitance is farad. How much it is offering? That offered resistance is given in terms of the farads. The value of capacitance depends on the area of the conducting plates, thickness of dielectric material, and its permittivity. Generally, the frequency of operation depends on dielectric type which we are used. All these values, these points are effects on the capacitance. The value directly they mentioned, the value is in terms of the microfarad or farads, but the capacitance is depends on the area of the conducting plate, the plates which we are using, how much it having the overall area, and the thickness of the dielectric material, how much thick it is. Depending on thickness also the capacitance may changes, and the permittivity, how much it having the permittivity capacity for the dielectric material, and the frequency of the operation, whatever the frequency of the operation also depends on the what type of dielectric we are using. This is about the capacitance specification. Second specification is dielectric constant. Dielectric constant means what type of dielectric we are using, that having that specific constant value. Dielectric constant indicates the ability of insulator to concentrate electrical flux. How much it having the insulating capacity, how much it will gather the electrical flux when we are applying the voltage, that is given as a dielectric constant. It is specified in the data sheets, this much of dielectric constant having the this capacitor. Next one is the dielectric strength. Dielectric strength is ability of dielectric to withstand a potential difference without breaking the dielectric, or it is the maximum voltage up to which the capacitor's dielectric works without breaking. The meaning is each dielectric having its own capacity is there. If you apply the voltage more and more, that dielectric material may goes into damage or may goes into a burning stage. So in order to avoid that, we need to know the strength of the dielectric. What the dielectric strength states that it is the ability of the dielectric to withstand to a potential difference without breaking the dielectric. Without breaking the dielectric, how much voltage we can apply, that voltage is nothing but a dielectric strength. This is also very important factor. Whenever we are using the capacitor, we need to check whether the dielectric strength is matching to our application or not. The next one is the tolerance. Already you know the tolerance. Tolerance. Tolerance is the variation of capacitance value from its original value. The meaning is each component having a particular specified value is there, but whenever we are using that component practically, it may have some correction. Some correction means it may have either positive or negative, where negative band of tolerance is there. Negative band of what you say thing is there. So that is called as the tolerance. The tolerance is the variation of capacitance value from its original value. If the original value is 40, how much variation it have, we taken as the same value. That is in the positive, how much percentage we are using. Generally this tolerance is mentioned in terms of the percentage. Tolerance is mentioned in terms of the percentage. The next another important specification is the working voltage. Working voltage. What is the working voltage? Working voltage is the maximum voltage up to which the capacitor can operate without fail. The meaning is, before what we think discussed is dielectric strength. What dielectric strength state that maximum voltage with the dielectric withstand is given by the dielectric strength. Now working voltage is nothing but what is the maximum voltage up to which the capacitor does not goes to damage, or the capacitor will work without fail, is called as a working voltage. Why? Because if you low working voltage capacitor used in the high working place, it may goes into the damage. It may alter the function of the our required circuit. That is called as a working voltage. That is the importance of the working voltage. Working voltage is usually rated in the DC value, direct current DC value. Working voltage decreases with rise in frequency of operation. If the frequency of operation is increases, the voltage will be decreases. The meaning is if frequency increases, the capacity of the voltage is decreases. Working voltage mainly depends on dielectric material used in the capacitor. What type of dielectric material we are using, that is depends on the, that is affects the working voltage. So once again, working voltage is nothing but it is the voltage, or it is the maximum voltage up to which the capacitor can operate without fail. The next one is the dissipation factor. This is also a important specification. What is the dissipation factor? This is the measure of loss in dielectric of capacitor. What dissipation factor says that how much of loss will occur in the dielectric. Whenever we are using the dielectric as a storage, storing in the capacitor, it stores the energy, and that how much it having the storing capacity, and in what rate the dielectric is dissipating the energy, dissipating the discharging the energy we need to know. Otherwise the dissipation is very fast, it does not get the our required operation. So that is the dissipation factor means this is a measure of losses in dielectric of a capacitor. What are the losses are in the dielectric, in what way the losses occurring in the dielectric is given by the dissipation factor. Dissipation factor is a tan alpha, where alpha is dielectric loss angle. Alpha is the dielectric loss angle. Dielectric loss angle depends on how we can calculate the loss angle. Alpha is nature of dielectric material we are using, what type of nature it having, frequency operation, whether what type frequency it will be useful. For low frequency, how it is, high frequency, how it is, depends on the frequency of operation also the alpha will be decided. Temperature at which capacitor is using, in what environment condition, in what temperature conditions we are using the capacitor. So that is also is called used for the measurement of alpha. Voltage applied to the capacitor, how much voltage we are applying to the capacitor, that also is used for the, that also used to calculate the dissipation angle. So dissipation factor, once again you can see dissipation factor is measure of the losses in dielectric of a capacitor. This measure of the losses is measured by using the dissipation factor is tan alpha. The alpha is calculated, or alpha is depends on nature of dielectric material we are using, frequency of the operation we are performing, temperature at which the capacitor is using, where what type of how much voltage we are applying to the capacitor. All these factors affect the alpha. So this value is given in terms of the data sheet. The next specification is the power factor. So this is also a important factor whenever we are choosing the capacitor. The power factor indicates the quality of a capacitor in terms of minimum losses. The meaning is the power factor indicates that how much loss will occur for this capacitor. So by using this factor we can identify the capacitor is worthful or not worthful. So that is the power factor, also very important. The power factor is indicates the quality of capacitor in terms of minimum losses. Power factor is indicated by cos alpha. Alpha is the loss angle, cos alpha. The next one is the equivalent series resistance. So the equivalent series resistance means this specification indicates that this parameter indicates the losses inside the capacitor due to the material opposition, or due to the type of material we are manufacturing for these leads. All those gives the losses inside the capacitor. That is called as a equivalent series resistance. When we connected in series or whatever maybe, how much resistance of this capacitance is offering, that value is nothing but a series resistance. Next one is the leakage resistance. Leakage resistance means a certain amount of current flow through capacitors dielectric material is called leakage resistance. What we are using is perfectly insulating material in the capacitor in between two plates of the capacitor. The main purpose of the insulator is not to pass any current through the dielectric material. But if this is in the ideal case. In the practical case, always we may have some correction. So in the practical case, certain amount of current flows through the capacitor dielectric material. So this flow of material is in the form of the loss, or it may be in the form of the heat. So this is called the leakage resistance. How much of the current flowing, that amount of resistance is called as a leakage resistance. You can also know this type of thing whenever we are connecting what portion is entering into the dielectric material. Generally it is negligible. Whenever you use the any critical applications, we need to consider all these parameters. And next specification is insulation resistance. What is the insulation resistance? It is the resistance measured across the terminals of the capacitor at specified voltage and temperature. The meaning is, so the resistance which it is offering whenever applying the specified voltage in the condition specified temperature, how much resistance is we are getting across the terminals, that resistance is insulation resistance. Should know how much resistance it is offering. It is generally expressed in mega ohms, that is called as the insulating resistance. Next, another one is the temperature coefficient. Temperature coefficient of the capacitor. This parameter indicates the change in capacitance value due to change in the temperature. Change in the capacitance value due to change in the temperature. When the temperature changes, how much capacitance value is changing. So this is given by the parts per million per degree centigrade. Parts per million per degree centigrade. Per degree centigrade, how much the capacitance is changing. This is also very important. If the environment is temperature sensitive area, we also consider this change of the value, that is a temperature coefficient. So this is the another important coefficient. This parameter indicates the change in the capacitance value due to change in the temperature. Next one is the voltage coefficient. So what is the voltage coefficient? So this parameter indicates the change in the capacitance value due to change in the voltage. This is the another parameter. Whenever we are applying the voltage also, some of the capacitance value changes. So that is even given by the voltage coefficient. The units of this is parts per million per volt. For volt, how much of this capacitance value is changing. This is also important. Whenever we are applying the voltage, if voltage applies, the capacitance changes. We need to know how much it is changing, how beyond it is changing. Then only we can use this particular component. This parameter indicates the change in capacitance value due to change in the voltage. The factors affecting the capacitance of a capacitor. What are the factors? This is another topic which we are going to discuss. What are the factors affecting the capacitance of a capacitor? We need to know each and every part. We know the capacitance of a capacitor is given by epsilon A by D. We know that the capacitance of a capacitor is C equals to epsilon A by D. Epsilon is the permittivity of the dielectric material. A is the area of the plates. D is the distance between the plates. You know already the capacitance depends on the plates area, plates distance, and the material we are using in the plates. Area of the plates, distance between the plates. Epsilon is the permittivity of free space, you can see. So these are the main factor which affects the capacitance. Epsilon r is the relative permittivity. So now we try to understand this one. Capacitance of the capacitor is directly proportional to the area of the plates. The capacitance value, if the area is increases, capacitance value increases. The capacitance value of increases increasing the area of the plates. Capacitance of the capacitor is inversely proportional to the distance between the plates. That is, if the distance between the plates increases, the capacitance value decreases. We know that. So the thing is, the area increases, the capacitor's plates area increases, automatically capacitance value increases. The distance between these two plates are increasing, capacitance value decreases. The meaning is, the capacitor plates are nearer, then the capacitance value is high. If the distance between plates decreases, the capacitance value increases, as I mentioned. The capacitance value is directly proportional to the permittivity of the dielectric. If the permittivity of the dielectric is more, the capacitance value is more. Dielectric constants, different materials are given below. You can see. So what are the different dielectric constants? You can see the craft paper, the dielectric constant is 2 to 6. Paper wax, we having the, you can see how it is. We having the first vacuum having the dielectric constant is 1. Air we having the 1, and the polystyrene we having the 2.4 to 2.6. So the dielectric constant also important because the capacitance value depends on the dielectric constants. That's why polycarbonate, these are the materials which we are using as a insulating material or dielectric material in the capacitor. Polycarbonate 2.8 to 3.1, mylar 3, polyethylene 2.1 to 2.2, polyester 3.0 to 3.3, polypropylene 2.1 to 2.2. Kraft paper we having the 2 to 6, paper waxed paper having the 4 to 6. You can see mica having the 4 to 7 dielectric constant, aluminium oxide 7 to 10, tantalum oxide, this is a very dielectric strength, we having 27 to 28, ceramic low loss type we having the 7 to 20, ceramic temperature compensating type we having the 80 to 100, ceramic high permittivity we having the 1000 to 5000. Very high dielectric constant is for the ceramic, high permittivity. If you use the glass, that is a 7.6. So from all this dielectric constant, if ceramic high permittivity is used as dielectric, the capacitance is more. We need to know all these dielectric constants of the different material. Whenever we are manufacturing, it is useful. So you can say area of plate is 5 millimeters. Glass is used as dielectric 7.6, and diameter is 0.1 centimeter. Then find the capacitance. You can see one example. Area of the plate is 5 millimeters. Area given. Glasses is used as dielectric is the 7.6 given, and the diameter distance is given 0.1 centimeter. You know the capacitance equal to epsilon A by D. You know the A, you know the D. Epsilon equal to epsilon and epsilon. Epsilon means he given 7.6. Epsilon is the as free air permittivity 8.85 into 10 power minus 2. If you calculate, then you can get the capacitance value. Okay, that is a simple example. If the thickness of dielectric is reduced, higher capacitance can be obtained, but reduction in thickness of dielectric causes breakdown of dielectric due to potential difference between the plates when we charged. The meaning is the dielectric we need to choose how much length or width it should have. We need to choose in the proper way. That is, if the dielectric thickness is very less, the capacity is increases, but if you apply the voltage, what happens means the dielectric may not withstand with that particular voltage rating or working voltage and dielectric strength, all are depends on the dielectric material width. So that's why the thickness of the dielectric is moderately we need to have. If you reduce, the higher capacitance can be obtained, but this reduction causes the breakdown of the dielectric. So in order to avoid that, we need to choose the a moderate dielectric. So next one is the dielectric strength. We know that already we discussed earlier. Dielectric strength, a maximum potential gradient that a insulating material withstand without rupture. The meaning is maximum voltage or maximum potential we can apply for the dielectric material without having any damage. Practically it is breakdown voltage divided by the thickness between the electrodes. How much thickness we have and the breakdown voltage it having. This is expressed in volts or kilovolts per unit thickness of the material. Dielectric strength of material depend upon temperature and humidity. The strength of the dielectric is depends upon the what temperature condition we using and what humidity conditions we are using that material. Now you can see that temperature and dielectric strength of different material. Last we discussed about the dielectric constant we discussed. Now we try to see what is the dielectric strength. The thing is there is a maximum for the maximum voltage how it can withstand, that is given by the dielectric strength volts per millimeters. The air we having the 1, vacuum we having the 1, aluminum oxide we having the 7, ceramics we having the 80 to 1200, and the glass having the 8. Mica we having the 3 to 8, oil we having the 2 to 5, paper we having the 2 to 6, plastic film we having the 2 to 3, tantalum oxide also having the a maximum value, that is a 25 we having. Dielectric strength, you know that every insulating material possesses an electrical capacitance. Every insulating material possesses an electrical capacitance. This capacitance depends on dimensions and kind of dielectric between the plates. What dimensions, what thickness or width and breadth of these there, and in between the two dielectric plates. Thus, of dielectric constant is measure of its ability to form an electric capacitance insulating material. We can say simply dielectric strength or dielectric constant is measure of its ability to form an electric capacitance insulating material. So dielectric constant is not constant but varies with temperature and frequency. If the temperature changes, the dielectric constant also changes. If the frequency changes, the dielectric constant also changes. That's why we can say that dielectric constant is not constant but varies with temperature and frequency. It decreases with the increasing in frequency due to inability of polarizing charges to follow the electric field variations. Why it is decreases with the frequency means it is the frequency is rapidly changes, polarization also changes. This polarization follow the electrical field variation. That's why it may decreases as the temperature is changes. So you can see dielectric constant we have in the quartz glass 3.78, window glass 7, electrical glass 6.6, ferrex 4.6, polystyrene 2.55, polythene 2.25 to 2.32, Teflon 2.2, PVC we having the pi to 6 we have. So these are the different dielectrics. So now we are going to discuss about some of the fixed capacitors. We already discussed. Now some of the capacitor we try to discuss. Some fixed capacitors are paper, mica, glass, polyester. The next one is the polystyrene, ceramic, electrolytic. These are the some of the fixed capacitors. We last class we discussed some of the capacitors how they are manufactured. So these are the some another capacitors. Some are repeated: paper, mica, glass, polyester, polystyrene, ceramic, electrolytic. So we know the what are the properties of capacitors. Now we try to discuss about the properties of capacitor. So what are the properties means capacitance range, tolerance, working voltage, operating temperature, power factor. So these are the properties of the capacitor, are also maybe these are also the specifications of the capacitor. Generally we need to know important one is the capacitance range, tolerance, working voltage, operating temperature and power factor. Now we try to discuss about these capacitors, fixed capacitors, how they are. Tubular rolled paper capacitor. This is one of the capacitor. How what type of properties it have? So we try to discuss the properties of the capacitor. In the property of the capacitor, what type of capacitor we are using, so that should know. So first, what properties we need to see for each of the capacitor is capacitance range, tolerance, working voltage, operating temperature and power factor. So that is for the tabular rolled paper capacitor. How it having the total capacitance range of this tubular rolled paper is 0.05 to 1 microfarad. It having the capacitance range. Tolerance is 10 to 20%. It having power factor is 0.04 to 0.01 microfarad. Already you know. Maximum working voltage is until 1000 voltage. This tubular rolled capacitor is used. The operating temperature is 85 degrees centigrade to 125 degrees centigrade. So where we are using the tubular rolled paper capacitors are coupling and decoupling in audio frequency circuit. To coupling the circuits, decoupling the circuit, we use the tabular rolled paper capacitor. One another type of capacitor is the metallized paper capacitor. Metallized paper capacitor. So what are the properties this metallized paper capacitor have? The capacitance range is 0.05 to 1 microfarad. That is the available range of the metallized paper capacitor, and the tolerance is 25%. Power factor is 0.005 to 0.015 microfarad. It having the maximum working voltage of this capacitors are 400 volts. The operating temperature is 85 degrees centigrade to 125 degrees centigrade. In this range, the value is given the proper value. So what the value we are expecting, that value is given in this temperature range. The application is same as that coupling and decoupling of the audio frequency circuits. We are using the metallized capacitor. Tubular paper capacitor we discussed. The next one is the metallized paper capacitor. So another capacitors is the polystyrene capacitor. So what are the what it having? Polystyrene capacitor means the capacitor range is 100 picofarad to 0.5 microfarad. The range of this polystyrene capacitors is 100 picofarad to 0.5 microfarad. Then the tolerance generally it having 0.5 to 5%. So what are the value is in that value 0.5 to 5% of tolerance is there. Power factor is 0.002. Having the working voltage is 125 volts to 500 volts. It having the maximum working voltage. In between it may work 125 to 500 volts. And the temperature is less comparatively. Operating temperature is 65 degree to 85 degree centigrade. More than that it may goes to damaged. The temperature range is less 65 degree centigrade to 85 degree centigrade. Generally this is used in resonant circuits, coupling and measuring circuits. We are using the polystyrene. The resonant circuits, these for the tuning purpose we are using this resonant circuit. Coupling measuring circuits, to couple the measuring circuit with the measurement, we use this type of capacitors. This is the polystyrene capacitor. The capacity is 100 picofarad to 0.5 microfarad. Another important one is the operating temperature is less 65 degree to the 85 degrees centigrade. So another capacitor is the polyester capacitor. The last capacitor is the polystyrene capacitor. This is the polyester capacitor. The polyester and means the meaning is here we use the dielectrical material is the polystyrene. Depending on the dielectric material only the name is given. Other one is the polyester capacitor. Polyester capacitor means the dielectric material is polyester. The capacitance range is 0.05 to 2 microfarad. The tolerance is 10 to 20%. 10 to 20%, and power factor is 0.005. The maximum working voltage is 500 volts, and operating also is less, that is same as the polystyrene capacitor, 65 degrees centigrade to 85 degrees centigrade. These polyester capacitors are used in coupling and decoupling and smoothing the circuits. So we want to use these circuits in the coupling the two circuits, decoupling the two circuits, and smoothing the circuits. Smoothing means, so these are smooth means some avoid the some noises unwanted AC signals are avoided, or some DC signals may be avoided, or the waveform is smoothed by using these capacitors. Next one is the stacked mica capacitor. One another type, stacked mica capacitor. The capacitance range is 50 picofarad to the 0.01 microfarad for this mica capacitor. The tolerance of this mica capacitor is 5 to 20%. We are having the tolerance range is 5% to the 20 percentage. The power factor is very small, 0.001 to 0.005. Maximum working voltage is 2000 volt. Mica having the more capacity means higher voltages we can use this mica capacitor. That range is 2000 volts means very high voltage we can use the mica capacitor. But the temperature, operating temperature is less, that is 85 degrees centigrade and above. 85 degrees centigrade we can use this mica capacitor. So generally this is used in radio frequency coupling and bypassing circuit. Bypassing circuit means whenever if you wanted to bypass the signal, AC signal not entering into the main circuit, we use this bypass capacitors. So just like it is used as a filter. Filter means they bypasses the AC signal through the ground to the ground. At that place we are using the mica capacitor. Mica capacitor, the advantage is the working voltage is very high. Working voltage is 2000 volts. Next one is the silvered mica capacitor. Another type is the silvered mica capacitor. The silver mica capacitor range is 10 picofarad to 0.1 microfarad. Tolerance is 0.5% to the 20%. Maximum working voltage also is more, that is 1000 volts. Silver mica capacitor and last mica stacked mica capacitor also having the high voltage, working voltage ratings are there. Operating temperature is 85 degrees centigrade and above, same as the stacked mica capacitor. Generally this is used in radio frequency resonant circuits and the measuring circuit. Radio frequency circuits and the measuring circuits are used the silvered mica capacitor. So this is the another capacitor generally which we are using. So next one is the silvered ceramic capacitor. Silvered ceramic capacitor. The silvered ceramic capacitor, the capacitance range is 2 picofarad to 0.001 microfarad. The meaning is silvered ceramic is used as a dielectric material. That's why it is called as a silvered ceramic capacitor. The tolerance is 1% to 20% tolerance is there. In that variation we get the components. The power factor is 0.001. The maximum working voltage is somewhat less compared to the other type of ceramic capacitor, that is the 350 volts. Working voltage is 350 and the operating temperature is 85 degrees centigrade and above, already we know. So this type of silvered ceramic capacitors are used in radio frequency amplifiers and radio frequency bypass circuit. So these circuits are used in the amplifier circuit. In the amplifier sometimes we need to allow the AC, sometimes we need to block the DC. So wherever you want to allow, at that place we use this capacitor. Capacitor as a passing element depending on the frequency. So these are the another type of capacitor, silvered ceramic capacitor. The capacitance range is 2 picofarad to the 0.001 microfarad and the maximum working voltage is 350 volts. So generally used in the RF amplifiers and the RF bypass circuit. So these are the some of the ceramic capacitors. The next one is another one is another one is ceramic with high dielectric constant capacitor. Ceramic with high dielectric constant. This type of capacitors having the capacitance range is 50 picofarad to 0.01 microfarad. The tolerance is 20 percentage. The power factor is 0.01. So maximum working voltage is the 350 volts as the last capacitor it having. The temperature range is 85 degrees centigrade and above. This is used in the various electronic circuit, that is the ceramic with high dielectric constant capacitor. So another one is the electrolytic capacitor. We having the here we use the aluminum electrolytic capacitor. Aluminum generally we have two types there. Aluminum is there, tantalum also there. So what is the electrolytic capacitors? In the aluminum electrolytic capacitor, the capacitance ranges we have 2 to 2000 microfarad, 50 to 1000 microfarad. We having the tolerance is 20% range is there, 50% also there. The power factors are 2, 0.02 to 0.2, 50 to 200. So generally the working voltage of maximum is 600 volt for these electrolytic capacitors, and the temperature is 85 degrees centigrade to the 120 degrees centigrade. So generally these electrolytic capacitors are used in low values are used in rectifiers, filters and smoothing circuits. We are using smoothing means wave shaping circuit, rectifier, filters and smoothing circuit. The higher capacitance values are using in decoupling and bypassing in the audio frequency circuit. In the audio frequency we are using this type of high frequency, high capacitance value aluminum electrolytic capacitors. So another one is the in the electrolytic capacitors, another one is the tantalum electrolytic capacitor. Tantalum electrolytic capacitor. The capacitance range is 1 to 2000 microfarad. Very high is there. Tolerance is 25 percentage. The power factor is 0.0 to 0.2. Maximum working voltage is 6 to 150 volts. The minimum is 6, maximum is 150 volt. The operating temperature is 85 degrees to the 120 degrees centigrade. So this is used in the coupling, decoupling, bypassing in transistor amplifier circuit and PCBs. We are using the tantalum type electrolytic capacitors. These capacitors main advantage is the we are used in the PCBs. We are used in the PCBs. So that is the advantage is the PCBs. So electrolytic capacitors we have two types, aluminum electrolytic and the tantalum electrolytic capacitors. Generally used capacitors are these capacitors. So aluminum also very advantage, that is used in rectifiers, filters and smoothing circuit we are using. So coming to this tantalum electrolytic capacitors used in the mainly PCBs, we having the PCBs bypassing, and in the decoupling coupling we are using this type of electrolytic capacitor. So in the today class we are discussed about in detail specifications of the capacitors. So different properties of the capacitors, of the different capacitors we discussed, ceramic capacitors, electrolytic capacitors, in so many different varieties of capacitors, and each capacitor properties we discussed and we compared and we understand the class specification and properties of the different capacitors. So next class we try to discuss about the remaining topics of the capacitor. Thank you. Thank you. If we have any doubt, you can ask me. I will clarify the doubts. So thank you.